Good morning, everyone. Hopefully everybody's enjoying their day. It's a Monday morning. Today's actually Sunday here. Beautiful day outside right now. So I'm coming to you from my back deck just to kind of enjoy myself and enjoying the sunshine a little bit while we still can before it gets too cold. It is crazy windy, so hopefully that doesn't mess with the sound too bad. I got my trusty AirPod Pros in, so hopefully that works out pretty well for you. Today, hopefully you looked at everything. You saw what we have going on today. You saw the starter in there. It was just a bonding review, looked at ionic bonding. That should have all been reviewed. It should have been stuff that we've done before that you guys can, just a refresher really. And then we introduced covalent bonding. Covalent bonding, the biggest difference with it is ionic bonding is a metal and a non-metal. Okay, remember the metals are going to give, the non-metals are going to take. In a covalent bond, we have two non-metals that are actually bonding together. These two non-metals are going to be sharing electrons. So there's no give and take here. They're going to be sharing them together. A lot of covalent bonds that we see involve atoms bonding with themselves, F2, O2, N2, Br2, carbon. So it's a lot of bonding with itself, which you see a lot of through covalent bonding, but it doesn't always happen that way. The first example that I gave you is a fluorine atom that is going to bond with itself. It's F2. It's two fluorine atoms that are bonding together. I wanted to walk you through that so you kind of got an idea of how to do that. The biggest thing that I want to tell you is octet rule is still in play here. They still want to get to 8. Okay, every atom still wants to get to its 8. The other thing is, when we talk about non-metals, those noble gases still not going to do any bonding here. They don't want to. Okay, they have their 8, they don't need to. Okay, so it's still trying to get to that octet rule, still trying to get those 8 valence electrons. Ionic bonding, we give and take. Covalent bonding, to get to the 8, what we do here is we simply share. So let's jump right into it. Let's look at it. All right, when we look at fluorine, I got my trusty little whiteboard right here that I'm going to use. When I look at fluorine, the first thing we want to do is draw out the Lewis structure for fluorine. So as I do that, on my whiteboard, I'm going to draw my F, okay? All right, that represents my fluorine atom, and then I want to draw in the valence electrons in a Lewis structure form. We know how to do that. It's the dots that go around the outside. So I have my 1 dot here, 2, 3, 4, 5, 6, and 7. We know fluorine has 7 valence electrons. Okay, so we have a pair up here, we have a pair over here, we have a pair over here. We don't really want to break those up. It needs 1 electron to get to its 8. Okay, so this electron right here needs to find a buddy, it needs to find a pair. In an ionic bond, it would just find a metal and take the electron. Covalent bonds, it's going to want to share this electron. All right, so we're looking at F2. Okay, so we need another F. We need to draw in another fluorine atom. So I draw in my F here. Okay, boom. I have 1, 2, 3, 4, 5, 6, and then its 7 is right here. Okay. Again, this fluorine atom, pair, pair, pair. We don't really want to mess those up. It's these two atoms right here, these two unpairs. This is where the magic is going to happen. This is where the bond's going to take place. This fluorine atom and this fluorine atom are going to share these 2 electrons. Okay. So they're actually going to share them. So as I start to do my count, okay, notice that these 2 are shared. As I do my count to get to my octet, I see 1, 2, 3, 4, 5, 6, 7, and then it's sharing, so here's 8. Same thing over here on this side. I have 1, 2, 3, 4, 5, 6, 7, and then it shares to show 8, okay? So that's how we get to our 8 through covalent bonding. That's the sharing that takes place. Now, ways we represent that, we don't just circle them, okay? That's not really how we want to do it, okay? The way that we represent that is if I have an electron here and I have an electron here, we show that bond by just showing a straight line, okay? That line right there represents the bond between the 2, okay? So as I show that straight line, that bond right here is the bond between the 2 atoms. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The straight line shows the bond. Okay? So that's for fluorine. Pretty straightforward, pretty simple, pretty easy.